Hello everyone, let's cache some knowledge. I want to talk to you a little bit about the different kinds of scientific studies and how they rank in terms of reliability. I get really worked up whenever I'm arguing with someone about an issue related to health and fitness, and they start saying something like, research shows X, Y, and Z, or I read a study that proves this, that, and the other thing, but they fail to address one of these three or even all these 3 points. 1. They don't actually provide the source. 2. They don't actually say what kind of study it was. 3. They don't acknowledge the limitation of the study. Aside from it being good manners, addressing those 3 points can help move the argument along and get it closer to the truth. When you don't do that, it immediately signals to me that you aren't interested in the truth as much as you are winning the argument. And I'm really not all about that. Well, maybe a little bit. 1. If you're going to make a claim, provide some source of support. 2. Understand that there are different kinds of studies and they're not all created equal. 3. Get used to knowing the limitations of the study. It keeps you humble and also tells you how far you can go with the claims. Now that that's out of the way, let's get to work. Not all studies are created equal. The information you get from some studies is a lot more reliable than others. Here's what I mean. One of the ideas behind the scientific method is that other scientists and researchers must be able to replicate the research and the finding. So when a study is replicated over and over by different researchers, the findings are compared and certain patterns begin to emerge. We can then see the similarities, differences, limitations, etc., and get the best possible answer. And at the end of the day, science gives us the best answer, not necessarily the right one, but that's okay. So here we are, the pyramid of reliability. Right at the top we have meta-analyses. Meta-analyses are supreme. They are the cream of the crop. This is the most reliable kind of research because it is the combined statistical data from lots of different research studies from which a definitive conclusion can be drawn. This is important because it looks at what are the most salient and consistent findings in many studies across time. It would be incredibly difficult to do one major giant study on a subject and take into account people from different backgrounds, countries, ethnicities, age groups, health and fitness profiles, and so on and so forth. Gathering many different studies from different people and places and combining the findings brings us pretty damn close. Systematic reviews and randomized controlled trials are at a close number 2. Systematic reviews are critical assessments and evaluations of all the clinical literature on a subject. Findings from different scientists and researchers are compiled and synthesized, both quantitatively and qualitatively. In a systematic review, you take a summary of all the current literature that pertains to a specific research question. Something like, what age group is most affected by schizophrenia? Then you look at all the scientific databases and look for research papers that address this question. You want to be as specific as possible. Randomized controlled trials are controlled clinical trials where people are randomly assigned to either an experimental group or a control group. Researchers testing the efficacy of a new drug, for example, will give it to an experimental group, while the control group would get a placebo or nothing at all. These kinds of studies can also be single-blind, where the groups don't know what they're getting, or double-blind, where neither the groups or the researchers know what is being given. This helps eliminate as much bias as possible. At number 3, we have cohort observational studies. This is where the reliability of the studies starts to get a little murky. Cohort observational studies are where subjects are observed over time and outcomes are either recorded or self-reported. Then they're compared. There can be many variables at play which can definitely impact the quality of the finding. Remember, the data is only as reliable as the instrument that is used to obtain it. If that instrument is the human brain, you're gonna have all kinds of sorts of biases affecting the outcomes. The case is particularly challenging when people are self-reporting because people can sometimes lie, cheat, and steal. This does not make them bad studies, but it does add to the list of limitations and definitely gives scientists ideas on how to better control and refine future research. Number 4, case control studies and case reports. This is where scientists take one group of people who have a certain condition, like diabetes for example, and compare them to a group of people that doesn't have the condition. These studies are useful in some sense because they are much cheaper to conduct. When compared with other types of research, they can usually be done in small teams, even by a single person. But because they rely so heavily on observation, the quality of evidence evidence, and the reliability of the information obtained from them is much lower than other studies. That being said, they can be very useful in helping to point the way towards what researchers should focus on more deeply. And last but not least, right at the bottom at number 5, we have animal testing. In terms of reliability, animal research is right at the bottom of the pyramid, and for good reason. Specifically, we don't know how the findings and results will look like on humans. Simple as that. Scientists can definitely extrapolate some very useful and helpful data. They usually test on animals to see whether or not a hypothesis is valid or even worth pursuing. And there you have it. It's always a good idea to get critical whenever someone starts saying stuff like, research shows that, or studies prove X, Y, and Z. What kind of research? Was it done on animals? Because that brings the reliability factor way down. Was it a cohort observational study? Because my first concern is going to be around the biases of both the researchers and the subjects. The problem is that research with poor reliability can make for very sensational claims. As for example, in the case of aspartame being poisonous. Now people are afraid to drink diet pop because rats were given copious amounts of aspartame. Do you know the ethical implications you would have to consider if you were to do that kind of research on humans? If you really wanted to find out the effects of aspartame on humans, think about how much resources you would need, how much funding you would need. You would have to take so many different groups of people from so many different backgrounds. You'd have to split them up, give one group nothing but diet pop for a given time to eliminate any cross-contamination and other variables. You'd have to take a different group and give them diet pop and something else to test its effects when combined with something else. Then take another group and lie to them. Tell them they're getting diet pop, but really just give them sugar. And then take another group, lie to them, tell them they're getting sugar, but really give them diet pop. All of that, and you would still not be able to come close to a definitive conclusion because there are so many other different variables and factors to consider. At the end of the day, my biggest issue is when people try to reorganize their belief system and try to convince me that I should do the same based on incomplete or very poor research. So, the next time someone wants to tell you about research they hear about or a study they've read, ask them, what's your source? What kind of study was it? What were the limitations? Think about it. Peace.